Hi everybody, this is the search engine project for the course of web information retrieval and data mining at the Eindhoven University of Technology. We are the group 6, compounded by Sanjaya, Serja, Camilo and Jared Baker. Our main goal in this project is to design and construct a Donald Trump tweet search engine system that retrieves tweets and information that users are likely to find relevant to their queries. Our data source is the Trump's Twitter archive. This source is a 4-year Donald Trump's tweets compilation. Our initial prototype is the following. We have a website in which we have an input box called search, in which the user can input any text and the tweet return or the different results that the web page will return will be the content of the tweet, the date that was created, the amount of retweets and favorites, and if it was returned, it was retweeted or no. We have also a page rank that will be showing the top 10 results. Our system design high-level view is the following. We will have a tweets database that will be hosted using the Google services called Firebase. Also, we have a two-part backend. Initially, we will have a Python backend that will be in charge of the index and query processing. Later, we have LD8 sentiment analysis and k-means processing. Also, will be made in Python. Finally, for getting the input, the queries, and showing the user the results, we will have a website that will be developed in HTML and JavaScript. In the part of the inverted Boolean index, we have in charge Jared Baker. Surya Chaudhuri will be in charge of the classification and supervised learning. Camilo Montenegro will be in charge of the k-means clustering as an unsupervised learning technique. Finally, Sanjaya will be in charge of the topic modeling and LDA technique for an unsupervised learning as well.
Indexing will be done using an inverted Boolean index method, which saves document IDs to each term in the dataset. The upside of this method is its speed and simplicity. Its downside, however, is that it usually returns too few or too many results. This can be tackled a bit by stramming the data in the pre-processing phase. Here we see an example of the indexing. I found a few Python libraries on GitHub that can do this job, and I will implement these with a slight tweak. The final results should give me a collection of documents including an occurrence number based on the query term.
Allocation is a data mining concept that can be used to describe important classes and to predict future data trends. There are two parts to classification. First is the classification itself into classes, and this classification model can be used for prediction. In classification, labels are defined and data is divided into these labels. For example, you can build a classification model to categorize bank loans as either safe or risky, and later use a prediction to determine future bank loans. The classification component of the project for this project is sentiment analysis of tweets. Sentiment analysis can be used to identify positive and negative attitude towards a topic, a person, or issue. For example, sentiment analysis can be used to determine the popularity of a candidate leading up to an election, or positive-negative opinion of the public on various social issues. In this project, the tweets from the US President Donald Trump will be classified as positive or negative based on a classified that is also trained on these tweets. To do this text processing, I will be using TextBlock, which is a Python library for processing textual data. The library can be used for things like term frequency and classification of words into subjective or objective. Firstly, we will use text block to identify the subjective words and identify which of these words are positive and negative based on the polarity prediction of text blob. Once we have made a list of positive and negative words, this can be used to further classify the tweets as positive or negative using, for example, the knife-based classifier.
In this project, we will be working with clustering. More specifically, we will be working with the k-means clustering. This is one of the symbols of popular unsupervised machine learning algorithms. The objective of k-means is really simple. It's to group similar data points together and discover underlying patterns. To achieve this objective, k-means look for a fixed number of clusters in a dataset. This fixed number is well known as the k-parameter. So, a cluster refers to a collection of data points aggregated together because of certain similarities. That's why our sub-goal of the search engine is to determine tweets topics by the text content with the purpose of filtering the results and retrieve the most relevant to the user. Our 3 steps implementation is the following. Initially, we are going to preprocess the data to remove the stop words, the internal links, and some emojis. The second step will be the word vectorization, and finally, we are doing the k-means algorithm with the Euclidean distance.
The last component for building the higher system is topic modeling. Topic modeling is a statistical method which is used for analyzing the words in a document and the hidden mixture of topics and how these topics are assigned to each words in a document. One of the best example of topic modeling is LDA. LDA discovers the pattern across a collection of documents and annotates the most relevant number of topics in a document. Why is LDA needed in building the higher systems? For example, we would like to find out the tweets which are related to politics from a large dataset containing all the Twitter tweets of Donald Trump. In such cases, we could use LDA to find out the number of topics. Python's skitlearn package provides a better framework for topic modeling using algorithms like LDA. The core package for implementing LDA is skitlearn. We also use other packages like regular expressions, spaCy, Genism for processing the text data. Given a set of documents, we process the textual data to build the topic models with skitlearn. For building the basic topic modeling using LDA, we need 3 parameters: the number of topics, the corpus, and the dictionary. We also see how to build the grid search and tune it for the optimal model. Finally, we would use PyLDA-Viz, a visualization tool for visualizing how these topics are related to the documents.
For the use cases, we have 3 main functionalities that a regular user will do. Initially, he can input the query for gathered tweets. This query is in the format of text. So he can make optional filter this query by date, topic, popularity, sentiment analysis. Afterwards, the user can browse the tweets, and all of these tweets, the top 10 tweets, will have the sentiment analysis. Finally, if the user selects any tweet, it can be redirected to the Twitter website and see the whole tweet at that query moment. Finally, for the implementation, we are using pre-existing tools. In the case of the inverted index, we are using Python and some libraries that will be really helpful for the indexing process. In the case of sentiment analysis, we are also using Python and TextBlob. In the case of k-means, we are using word2vec that is a library that permits to vectorize the content of the words. Also, we are using some Python main libraries that will be really helpful in the development of the k-means algorithms. Finally, in the LDA, we are using scikit-learns, latent direct allocation, or also we will try to use gensim.